Hello? Let us try to see the result when we divide f of x, which is 8x to the power of 5 plus 7x squared minus 3, by our g of x, our divisor, which is 2x minus 1, using synthetic division. So we are going to consider the coefficients of our dividend and a certain c coefficient found on our divisor. Now, in our previous attempts on dividing functions, we're able to use a factoring method and use the cancellation law for multiplication if there are terms or binomial expressions that can be cancelled out. In this case, since the highest degree of our dividend is 5, we have a lot of problems, or it would take us time in factoring this, and hence we're going to use the long division process. But instead of the long, we're going to use the synthetic division with this process. Let us try to consider the coefficients of our dividend. We have 8x to the power of 5. But we cannot place 7 automatically after 8 since our 8 is the coefficient of x to the power of 5, but there are no other terms with x to the power of 4 and x cubed. In this sense, we need to place a certain coefficient that will still describe the missing terms, but it will not change the entire value. Again, 7 is for x squared. So we don't have x to the power of 4. We don't have x cubed. So we can place here 0. 0x to the power of 4 is just simply 0. We're adding 0 coefficient, but we're not changing the value of the actual function. This is the same thing for x cubed. 0x cubed. Next would be x squared. That's why we have here 7. Again, we cannot place here minus 3 because we still have x, and that's 0x before you place here minus 3. So this is 8x to the power of 5 plus 0x to the power of 4, which is just 0. 0x cubed is 0 plus 7x squared plus 0x, or just 0, and then minus 3. That's the first consideration. Second is we are going to look for a certain c that will be placed here, and it patterns to this concept, x minus c. But notice that our divisor is 2x minus 1. Our c is not 1 because it should be x minus c, not 2x. What we could do here is we could divide both terms by 2 so that our first term will become x, and you have minus 1 half, because 2 divided by 2 is just 1, then you have minus 1 over 2, or 1 half. This means that our c coefficient is not 1, but more importantly, it's 1 half. It is also not negative 1 half because our structure here is x minus c, and since our operation is minus, we simply take out c, which is 1 half. Now we are going to place that somewhere here. Now that we are done with the coefficients, let's start with the actual process. First step is to bring down the first coefficient, 8. Next is to multiply this 8 by your c coefficient of 1 half. So 8 times 1 half, please don't forget your fractions, is equal to 4. Okay, again, bring down 8. 8 times 1 half, you have 4 here. And then you're going to add the coefficients. 0 plus 4, that's 4 here. Next step is to continue the previous process. 4 times 1 half is 2. So 0 plus 2 is just 2. Next, 2 times 1 half is 1. 7 plus 1 is 8. Okay? Next, 8 times 1 half is 4. 0 plus 4 is 4. And finally, 4 times 1 half is 2. Negative 3 plus 2, we have negative 1. This last coefficient is our remainder, and there is something that should be done in representing the result, considering the importance of our remainder, because if you're not going to place that remainder there later, the answer is incomplete and therefore it's incorrect. Now, our quotient will use these coefficients here aside from our remainder. This 8 here is the coefficient of the term using n minus 1 degree. That degree, or n, is referred to the highest degree of the original dividend, x to the power of 5, so that's 5. But here, 8 will not be the coefficient of x to the power of 5, but rather 5 minus 1, that's 4. So it's 8x to the power of 4. To be followed with this in decreasing order. Positive 4, so plus 4. Next term is x cubed. Then our 2 is for x squared, so plus 2x squared. And then you have your 8, so plus 8x. And finally, you have your constant of 4, plus 4. This is our complete quotient. 8x to the power of 4 plus 4x cubed plus 2x squared plus 8x plus 4. But there is something missing there, the representation of our remainder. Let's look at this concept. If we have 5 to be divided by 2, that's divided by 2, sorry. To be divided by 2. We can do it like this. 5 to be divided by 2. So there is 2. 2 times 2, you have 4. 5 minus 1, 5.4 rather, is 1. This is our quotient here, 2. This is our remainder. 5 halves could actually be written as 2 rather, and 1 half. 2 and 1 half. 2 is our quotient here. The 1 there is our remainder, and the 2 here is our divisor. This means that if we have a remainder, we could structure it like this. The quotient plus your remainder over your divisor. Okay, divisor. Why do we use plus? Because 2 and 1 half can be written as 2 plus 1 half. We already have our q here. This is our quotient. And considering our remainder of negative 1, we need to place a certain expression here rather. So first, since it's negative, so we will be using here minus. Negative 1. Or if you would like to use plus negative 1 here, because negative 1 is your remainder, because it's plus remainder here, it's still okay. But of course, you have different signs, so the negative will still prevail. Over our divisor of original divisor, 2x minus 1. This is now the more complete and the entire result when you divide your function f of x by your divisor g of x using this process of synthetic division. That's all for today. You're dismissed. And please do not forget to subscribe now.